Problem number 8. So we're given some information about the signs SIG and S of a couple of the trig functions, and we're supposed to use that to determine what quadrant angle theta must land in. Well, we can just use our All Students Take Calculus mnemonic to help us here. Look at letter A. I know that sine theta is positive. Well, of the big three, all of them are positive in the first quadrant, only sine in quadrant 2, tangent in quadrant 3, and cosine in quadrant 4. If sine is positive, that narrows me down to either the first quadrant, because everybody's positive, or the second quadrant. But then if cosine is negative, that takes out the first quadrant, so it's got to be quadrant 2. Okay, how about part B? Let's see, tangent is positive. Well, I could be here or I could be here. Secant, now secant doesn't fit in with the All Students Take Calculus, but secant is just the reciprocal of cosine. So if secant is negative, then I know cosine is negative as well. Well, again, the first quadrant is out then. Cosine is negative here in the third quadrant, so I must be in quadrant 3. Okay, the third one. Now we're given a value this time, but in terms of the quadrants, I really still just care about the positive or negative. So sine theta is positive 1/3. Again, sine is only positive in quadrants 1 and 2. Cotangent is negative. That means tangent theta would also be negative. Again, quadrant 1 is out, but tangent is negative in quadrant 2, so I must be over there. And then the last example, cosine is negative 1/10, so I got to go somewhere where cosine comes out negative. Well, cosine's positive in the first quadrant and the fourth quadrant, so it's got to be one of those two places. We also know that the sine ratio comes out negative. Well, sine is positive in quadrant 2, so that's out. I must be here in quadrant 3. Okay, and then number 9 refers back to this number 8, to parts C and D. Now that we know what quadrant we're working with, let's draw the full reference triangle picture for angle theta. So in part C, theta is a second quadrant angle. The sine ratio is 1/3. So I'm going to draw a second quadrant angle. Here's angle theta right here. And I can label the lengths of all of these sides. Sine is opposite over hypotenuse, or y over r. Again, using the reference angle, here's the little reference angle. If I refer to that, I can think opposite over hypotenuse. How about that third side? Well, I can get that just using the Pythagorean theorem. So I'll have x squared plus 1 squared equals 3 squared. That's x squared plus 1 equals 9. Subtract the 1. X squared will be 8. Square root each side. Remember, when you square root both sides, there's that plus or minus, and in this case, it does matter. I'm in the second quadrant. I can see that the x value is going to be a negative value because it's over to the left. So I will choose the negative, and when I simplify square root of 8, let's see, I can break 8 into 4 times 2. So a 2 comes out, leaving me with that other 2 left on the inside. So that side comes out to be negative 2 root 2. Part D, I'm drawing a third quadrant angle. I have cosine theta equals negative 1/10. So I'll draw something like this. Angle theta is this big angle right here. Although it's fine to just refer to the reference angle, which is this little thing right here, as I think about SOHCAHTOA. Let's see, cosine is adjacent over hypotenuse. Here's the adjacent side, that'd be the negative 1. The hypotenuse is always positive, so I know the negative has to go with the 1. And that would be a 10, negative 1 over 10. Or you could think cosine is x over r, negative 1 for the x and 10 for the r. Again, I can find the missing piece, which is the y value, using the Pythagorean theorem. Negative 1 squared plus y squared equals 10 squared. This will be a 1, this will be 100. Looks like I'll have y squared equals 99 after I subtract that 1. And let's see, let's think about the plus or minus. Do I need to worry about that? Yeah, I do, because in the third quadrant, y coordinates come out negative. So I have another negative here. And when I simplify, let's see, I can break 99 down as 9 times 11, and that's helpful because the 9 has a square root. That'll come out as a 3, and the 11 will be left behind. So there's my final labeling of that picture. Problem number 10, we're doing some labeling on some number lines. Letter A is very easy. It says start at 4 and then count by threes. You always have to count by the same amount when you have equally spaced tick marks. So I'd have 4, 7, 10, 13, 16, 19, and 22, counting by threes as I went along. Second example, start at 0, count by pi. So each little distance there represents 1 pi. Well, if I add another pi, I'd have 2 pi followed by 3 pi, 4 pi, 5 pi, 6 pi. Okay, now it gets trickier. I'm starting at pi and I'm counting by a half pi. I think we can probably do this one in our head. 1 pi plus a half a pi would be 1½ pi. 1½ is 3 halves as an improper fraction. So we write 3 pi over 2 for 1½ pi. If I add another half a pi to 1½ I'll have 2 pi, followed by 2½ pi. 2½ is 5 halves, so 5 pi over 2, and then 3 pi. And then 3½ would be 7 halves, so 7 pi over 2, followed by 4 pi. So 1, 1½ 2, 2½, etc. The last one is the hardest one because it's more difficult to do in my head. I know I'm starting at pi over 2. Each little distance represents pi over 6. I'm probably going to have to go off on the side here and do some calculating. I need to add pi over 6 to pi over 2 and figure out how much that is. I need a common denominator here of 6. So this is 3 pi over 6 that I'm adding to that pi over 6. Let me write it down below and I'll show you why. So what we've figured out is this here is 4 pi over 6. 3 pi over 6 plus pi over 6 is 4 pi over 6. The reason I wrote it down there is I can see it reduces, so it's not the final answer. I'm going to have to simplify it. But I kind of like to have it here because I know how to get all the rest now. I just need to keep adding yet another pi over 6. So 4 pi over 6 plus another pi over 6 would be 5 pi over 6. 5 pi over 6 doesn't even reduce. So I can just write it. The next one would be 6 pi over 6. That's going to reduce. So I'm just going to jot that down here for the moment. Then I'm going to have 7 pi over 6, followed by 8 pi over 6. That's going to reduce, followed by 9 pi over 6. That's going to reduce as well. All I got to do is reduce these other 4 and we'll be done. 4/6 reduces to 2/3, so this is 2 pi over 3. 6 over 6 here cancels. This is just pi. Let's see, 8 over 6 reduces to 4/3, so 4 pi over 3. And in that last one, I have a common factor of 3 that I can divide out. So it looks like this one simplifies to be 3 pi over 2. You can see, though, where not simplifying at first is so helpful. I was able to write down the answers so fast by keeping everything with a denominator of 6, and then I went back and simplified. Problem number 11 gives me some quick calculations to work out. I have values for A and B. Part A, I want to find A divided by B. That's probably the best way to even read it and write it, is just to use the little division symbol. It's the A divided by the B, which is going to remind me that, oh yeah, I can't do division of fractions. I have to change this to multiply by the reciprocal. So instead of -3/4, I'll multiply by -4/3. I think the only canceling I have here is 2 does go into 4 twice. And then when I multiply across, I can tell the final answer is going to be negative. A positive times a negative is a negative. And on the top, I have 2 square root of 5. And on the bottom, I have 3. And I'm done. That's the answer to part A. Let's see. In part B, I'm doing 1 divided by the A value. the root 5 over 2. I wrote 1 as 1 over 1 to make it look more normal. I'm going to have to change this to a multiplication problem, so multiply by the reciprocal. There's no canceling here. I'm just going to end up with 2 over the square root of 5. You know, I really probably could have done this a lot faster, because when I see 1 over a in math just means say the reciprocal. So I could have just turned the thing upside down. That is not the final answer, only because I have to rationalize the denominator. I can do that quickly, and it looks like the final answer here is 2 square root of 5 on the top, and then just 5 on the bottom, right? Root 5 times root 5 is just 5. 2 square root 5 over 5.